Hello everyone, welcome to today's live broadcast, The Stable Probiotic for Immunity in a New Intestine-on-Chip Model. I'm Sebastian Kravitz, editor of Nutritional Outlook, and I'll be your moderator for today's event. We're pleased to bring you this webcast presented by Nutritional Outlook and sponsored by Gnosis by Lesaffre. I will now share a statement from our sponsor. Gnosis by Lesaffre harnesses the power of microorganisms and biotransformation processes like fermentation to cultivate nutritional actives, probiotics, and nutritional yeasts that benefit human health and well-being. The team draws on its focused research and applications capabilities to collaborate with nutraceutical and pharmaceutical brands to develop game-changing products for their customers. We have a few important announcements before we begin. The webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them into the Q&A box, which can be found in the right-hand side of the screen. You can enlarge the slide window by clicking on the small square icon in the upper right-hand corner of the slide window, or by hovering your mouse over the lower right-hand corner and dragging the window to the desired size. The slides will advance automatically during the event. If you have any technical problems viewing or hearing this presentation, please click on the question mark help widget in the dock at the bottom of your presentation window. I would now like to introduce our speakers. We are pleased to be joined today by Julie Lomayu and Bertrand Rodriguez. With a background in chemistry, marketing, and food technology, Julie has spent 20 years in the field of marketing at food, nutrition, and health ingredients companies. She joined Gnosis by Lesaffre in 2020 and is leading the team dedicated to wellness and immune health. With a background in nutrition and health and a PhD in microbiology, Bertrand has spent 15 years in the field of probiotic, prebiotic, and microbiota research. He has joined Gnosis by Lesaffre in 2017, and he is leading the team for innovation. Julie, Bertrand, thank you so much for joining us today. Please get us started.
Yes, thank you. Thank you, Sebastian. Today, I'm very pleased to present you the stable probiotic dedicated to immune health, which is LifeinU BSCU1. And I'm really pleased to be with Bertrand, who will explain, let's say, a kind of revolution in terms of scientific model that we developed with a startup spin-off from Harvard. And Bertrand will explain everything on this new scientific model. Yes, just to complete a short word on Gnosis by Lesaffre, thanks to the Sebastian explanation, we understand that we work on the microorganisms through a biotransformation process, and we provide to dietary supplements and functional food industry some active ingredients, nutritional and functional yeast, and for sure probiotics, which is the subject of today. Just to introduce the subject, I want to give you a short overview of the market of immunity, which is, as you know, on the rise. And if we want to go deeply in this market, we wanted to explore the producers and the consumers' insight in the market of immunity and especially dietary supplements dedicated to immune health. What about the producer insights? From a producer point of view, probiotics is now well known to support the immune system. And following a market survey that we've done at Gnosis by Lesaffre with plenty of dietary supplement producers, 100% of respondents answered that probiotic is a relevant option, and for 50% of them a necessary option to be combined with other ingredients in order to design a new dietary supplement dedicated to immune health. Considering the other ingredients, we see three major categories in this field of dietary supplement dedicated to immunity, which is vitamins with vitamin C, vitamin D, B complex vitamins, the zinc, and the probiotic, which is the third category used in new dietary supplements. And now we see in the market that 27% of new dietary supplements dedicated to immunity contains probiotics. If we want to have a look on the consumer insights, let's say that probiotics becomes now the must-have to support immune system. And we see globally this trend in the consumer mind. We saw global market increase in the field of immunity, but it's not only due to the sanitary crisis. We see that for many years now, but even between 2020 and 2021, we see a strong increase of interest in the consumer mind to take probiotic in order to support immunity. We see this trend globally, especially driven by North America, plus 5% between 2020 and 2021, and Asia Pacific, plus 6% between 2020 and 2021. Then clearly, the probiotics becomes now the solution in the consumer mind to support their immune system. If we want to go deeper in the consumer insight, we see that globally, the strong interest in taking probiotics to support immunity is for Generation X. And we see this increase of interest of Generation X globally in APAC, North America, Europe as well, between 2020 and 2021. Then clearly, this is a target for designing a new dietary supplement in the field of immunity. What do the consumer expect when he buys a new product? The sustainability is, let's say, a must-have now when we develop a new product in dietary supplement, but functional food as well. And brands have strong commitments on sustainability. More they have a strong commitment on sustainability, and more the product is reliable in the opinion of the consumer. If we talk about sustainability, we can think about the principles of 3 R's, which improve welfare of animals used in research. And at Gnosis by Lesaffre, we think that there is some opportunity to develop new models in order to replace some kind of animal models, especially at the preclinical stage. Let's go deeper in the presentation and go straight to the key topics of today, which is LifeinU BSCU1, the stable probiotic dedicated to immunity, which is an efficient and sustainable option to target immune health benefits. What is LifeinU BSCU1? BSCU1, as mentioned, is a stable probiotic for 24 months. It's resistant to several different industrial processes, in dietary supplements for sure, but also in functional food. And its efficacy is proven by clinical studies, but not only a clinical studies. That's what Bertrand will present to you in a few minutes. And it's dedicated to support immune health. If we see the science behind the ingredient LifeinU BSCU1, we have, let's say, some strong evidence behind the ingredients. Some clinical studies, some new scientific models, and we worked on both sides, the symptoms and the mechanisms of action. And in terms of mechanism of action, we studied strongly the level of IgA in saliva and in intestine to see what is the effect of LifeinU BSCU1 on the immune system. Why we study the IgA? Because we know that with age, IgA level decrease and can lead to a higher sensitivity to common infection. And we can see many conditions which can impact as well the natural defenses, like conditions like intensive sport training, use of medication, or stressed modern lifestyle. And we think that IgA is a key marker of immunity that we need to study additionally to symptoms. What we discover in the clinical study, just a reminder of the result that we have presented last year, is LifeinU BSCU1 can support immune health in decreasing the frequency of upper respiratory tract infection by 45%. And we know, thanks to the group who received the LifeinU BSCU1 versus the placebo, that LifeinU BSCU1 induced a significant reduction of the frequency of those infections. What about the mechanism of action, and especially IgA? We mentioned that IgA is a key marker of immunity, and we measure the level, the concentration of IgA in human saliva and human stools, and we see that at the end of the study, we observe a significant increase by 87% of IgA level within the group who received the LifeinU BSCU1 compared to the placebo group. Those results are really important to mention because you will see in the following of the presentation the relationship between these clinical studies, the results we get in this clinical study, and the results we will get in the new scientific model that Bertrand will present to you. What are those new results on LifeinU BSCU1? Behind the ingredients, we have decided to launch a big program, a strong program of scientific study based on clinical studies, but also on new scientific model. But the question was for us how to be more predictive at a preclinical stage, how to go faster in order to provide faster some evidence on the efficacy of the ingredients, and how to get a more sustainable approach of our science. How we do that? We try to invent the science of tomorrow through different partnerships. And for this new model, to develop this new model, we worked with a spin-off from Harvard, which is named Emulate, and we developed with them a new dynamic preclinical model on immune health. And I will let the floor to Bertrand, who will explain everything on this, let's say, this kind of revolution in terms of scientific model.
Okay, thank you, Julie. Thank you for this kind of introduction. But let's talk about novelty now. It's true that in terms of predictions, classical models are lacking of translational between the result that we can obtain with the models and what we can surely predict in vivo trials in humans. We know that animal models are not so much sustainable right now, and we don't want to use them anymore at Gnosis. And they are lacking of contrastional evidence between what we can observe in this kind of models and what we can expect in clinical trials. Of course, there is the classical cell line models, so 2D cell line, which are too much simplistic, no interaction between tissues. So again, a lack of information that we can get from those models with the probiotics and for a next expectation in vivo trials. Last model derived from this 2D cell line is what we call the organoid suspension culture. So typically, these are cells that are taken from the body and made into culture in petri dishes. But the only thing is that they are not so much suitable for the use of probiotics because you need to inject a probiotic inside, so it's not easy. So we need some new models to reduce these translational failures and to be more suitable for the study and investigations around the probiotic effect. And as noticed by Lesaffre, we think that the gut on chips, so organs on chips, are maybe the solution. And one is the gut on chip that is developed by this company we partner with, which is called Emulate, based in Boston, USA. But with Emulate, we decided to go with the gut on chip. But what is a gut on chip? We need to say that a gut on chip is a 3D human-derived cell culture system, which can recreate a cellular microenvironment. So basically, you have in the middle of this slide, you have a description of a cartoon which shows how it works, how it is built. So basically, you have this device, very small device, in which you can recreate different compartments of the gut. The lumen on the top channel and the vascular compartment, so mimicking the blood circulation on the bottom channel. So this device allows us to have this tissue-tissue interface, which is really of importance once we want to study a probiotic effect. So on the top channel, you have studied the cell lines coming from the gut biopsies. So cells are cultured on the top channels, and on the bottom channels, you have cells coming from the vascular compartment of the body, so to mimic the blood circulation. This device also benefits from a dynamic system. So here, a dynamic system means that you can recreate the bowel movement, like in the gut, and you have also this flux of nutrients that goes in the lumen side of the epithelium, which recreate what you can get inside the body. And last but not least, this device can be also co-cultured with additional complexity, that meaning that you can add more cells coming from all the parts of the bodies to investigate the interactions in between those tissues. But what about the gut-on-chip with probiotics? There are not so many studies about probiotics and their use in such a system. One results coming from the literature is the use of the LRGG, so Lactobacillus rhamnosus, one of the famous probiotic strains in the world. And you can see in the study that, again, one specific asset of the model is the dynamic. And the dynamic was able to recreate conditions that allows the device to display results that are the same as the one we can observe in clinical trials. There are so many clinical trials about LRGG and its impact on the gut epithelium, for instance. And you can see on the graph in the middle that thanks to the dynamics of the system, we can recover the effective impact of LRGG on the gut epithelium, especially on the resistance of the gut epithelium. So how it's very tight, or how the cells are tightened all together to make a strong gut epithelium. You can also recreate the epithelium surface with the adhesion of the cells that are the same aspect that you can get in the reality of the body. And last but not least, we have to say that thanks to this kind of device, so the gut-on-chip, we can co-culture a probiotic like LRGG up to 1 week, which is clearly different of what we can expect from traditional models. But we want to talk about CU1 today. And CU1, as said by Julie before, CU1 has a strong impact on immunity and strong impact also on gut epithelium, which are the two basics that we want to use today, and we will talk about it later on in the presentation. But our Bacillus subtilis strain is a spore-forming bacteria with an impact on the gut epithelium. And you can see on the graph on the right side, upward side of the slide, that once you treat in vivo with the Bacillus subtilis and then make a challenge with an inflammatory component, you have the restoration. So the strength of the gut barrier is restored thanks to the treatment with the Bacillus subtilis. And again, Bacillus subtilis can have impact on the immune system. So you can see on the graph the increase in secretory IgA in the lumen of the gut during the treatment in the clinical trials with the Bacillus subtilis. And this increase was also associated with a lower frequency of respiratory infections. So these are two clear markers that we have observed in vivo that we will use later on with the gut-on-chip. But what about the use of our CU1 in this model? So we decided to go with an organoïd-derived intestine chip. So meaning that we started from cells coming from the AFC donors, a biopsy from AFC donors, which were cultured in the device to recreate the gut epithelium and the lower blood circulation compartment. And you can see on those pictures coming from 4 days, 6 days, and 12 days of cultivation of the cells in the system that thanks to the flux of the dynamic of the system, we were able to recreate the full structure, 3D structure of the gut epithelium as compared to the control with the static model. So you can see that there are so many villi, so the 3D structure of the gut epithelium that were built during this culture and not in the static model. If we want to go further in this development, we can go and have a look at the architecture of a villus, and thanks to this fluorescence microscopy, you can see that all the key components of the villus are represented in the gut-on-chip model and in a good and at a good place in the villus. So this is clearly a model that we can use to further study our probiotics impact. But you remember that we said that we want to investigate the impact of BSCU1 on the immune system. And thanks to the model, we can add complexity inside. And the complexity we want to use there in this specific development we made with Emulate was to add PBMCs, so cells coming from the blood, immune cells coming from the blood, and feed those cells right at the interface in between the epithelium layer and the vascular compartment, like the one we can observe in vivo in the guts. So we seeded all the PBMC cells right at the interface. And we can see on the pictures in the slide that the cells were seeded at the right place. So in red, you can see the immune cells just at the interface in between the epithelium and the vascular compartments. And those cells were living cells. So cells that we can use later to investigate the potential impact of our probiotics. But before going deeper in this model, we need to confirm that the probiotic will not have a deleterious effect on the model. That's for sure. So we decided to look at the morphology of the gut epithelium as well as the morphology of the vascular compartment in between chips treated with the probiotic and chips not treated with the probiotics. And you can see on those pictures related to 24 hours, 72 hours, and 120 hours of culture that there were no significant differences in between the chips that were treated and the chips that were not treated with BSCU1, meaning that there is no deleterious impact on the morphology of the intestine chip with the use of CU1. If we want to go a little bit deeper, we can have a look on specific markers of the good health of an epithelium. And you can see on the left of the slide pictures representing the expression of specific proteins coming from the tight junctions of the epitheliums. Tight junctions are like belts around the cells, maintaining all the cells of the epithelium tightened all together. So you can see that in comparison between the untreated chip and the treated chip with the BSCU1, there were no significant action of CU1 on that, meaning that the proteins were there in the same level of expression. And on the right side of the picture on the slide, you can see the effect of CU1 on permeability of the gut epithelium. And you can see that in all groups, there were no significant differences, meaning that BSCU1 has no deleterious effect on the permeability of the gut epithelium in the device. But now let's have a look at markers that we have already described before, and markers that are good indicators of the reproducibility of what was observed in vivo and what we can expect in this model. So we decided to start with some markers of intestine health and especially the expression of some ionic channels which are present at the surface of the epithelium. So typically the CFTR channels are down-regulated once you treat in vivo with the Bacillus subtilis, and it's part of its effect on the diarrhea recovery and so on. But you can see, so in this graph, that subtilis have a lower level of CFTR expression, and that was the same once we had a look in the gut intestine-chip. Okay, so lower expression with lower fluorescence in the picture of CFTR. That was the same for the TLR4, and again, that was results that were observed in vivo, and we were able to reproduce them in the gut-on-chip model. But we want to look at the immune system, immune impact of our CU1, you know. So, as you said, one of the markers that is correlated in immunity, thanks to the use of CU1, is secretory IgA, expression of secretory IgA. And so we decided to use this marker as the first step of confirmation of, the prediction we can get from this model and further on in clinical trials. On the graph you have on the slide, you can see the level of secretory IgA in the lumen part of the gut chip, and you can see that the groups that were treated with the probiotics, so LifeinU BSCU1, displayed higher level of secretory IgA as compared to control. So again, this is a good marker, and we can say that probably we can expect some prediction between the use of CU1 in such a model and the possible effect it can have in clinical trials, because again, we have expression of secretory IgA in the model, and we have already observed this in vivo in the clinical trial. So before I leave the floor to Julie again, I would like to give you some take-home messages. So first, the organoïd-derived intestine chip that we have developed with Emulate was used in combination with immune cells first. So first point to take-home messages, and we can use them with performing probiotics like LifeinU BSCU1. The co-culture we made with the LifeinU BSCU1 goes to some results that were consistent with the positive impact of CU1 that we have already observed in vivo, so positive impact on epithelial markers and positive impact on immune markers, typically secretory IgA. So we can say now that we have a good starting point to further explore the mechanisms of action of our probiotics and further use this model for predictions and possibly further understanding of the mechanisms of action of our probiotic before going ahead with more clinical trials. I would like to thank you for your attention, and Julie, this is for you again.
Thank you very much, Bertrand, for your explanation, really clear. Just if we want to conclude on LifeinU BSCU1, thanks to first of all, the clinical studies that we've made, and there's this new innovation in terms of scientific model where, Bertrand, you have demonstrated the positive impact of LifeinU BSCU1 on the immune system. We can conclude that LifeinU BSCU1 has a first protection demonstrated with a decrease of frequency of respiratory infections, and a second protection with less gastrointestinal infection thanks to the level of IgA increase. Then increased IgA concentration helps our body to better face infection, as we know, and maintaining a powerful immune system is key to stay healthy. And we think about LifeinU BSCU1, which is an efficient solution to support immune health. And in the field of immunity in the US, you can use the claim as LifeinU BSCU1 supports immune health. Then I want to thank you for your kind attention. Do not hesitate to ask some questions if you have some. We are open to answer. And if you need more details after the presentation, you can send us some email to ask you many things on LifeinU BSCU1, on other markets, other solutions that we can provide.
Thank you both so much for such an informative presentation. Before we get started on the question and answer session, I'd like to remind the audience how to submit questions. You can submit questions by typing them into the Q&A box, which can be found in the right-hand side of the presentation window. So let's begin our question and answer portion. Our first question is, can the intestine-on-chip model replace a clinical study?
Thank you, Sebastian. I will take it. Thank you for asking this great question. No, we cannot replace clinical trials with the gut-on-chip for sure. I mean, it's not the same kind of information you can get. But you have to realize that the gut-on-chip, talking about preclinical models, is really right now the model that can mimic as close as possible the condition of what we can get in vivo, in the human body. So not replacing, but getting more information about what's going inside, what kind of mechanisms of action you can have with your probiotic, for instance.
Terrific. Next question. It was explained that LifeinU BSCU could be used or could be dedicated to functional foods. Do you have some information regarding the taste of the probiotic?
I can take this one, Bertrand. The taste of LifeinU BSCU1 is mild and mainly related to the sweetness of the maltodextrin carrier, and then you can use in many different matrix without any compromise on taste. It's really neutral.
Okay. And because the intestine-on-chip model can expect faster analysis than conventional clinical study, how long will it take to get results in this new scientific model?
Again, I can answer this question. For sure, it's really fast. I mean, in comparison to what is a clinical trial length, for sure. It will depend also on the condition you want to test, repetition, and the kind of development of model you want to use. But for instance, in our case, it's about 3 months, 3 months work. 3 months lab work before having the results. So clearly, quite fast model if you compare the relevance of the information you can get from such a model in comparison to the length and effort you will put on a clinical trial to get information coming from in vivo.
Going back to functional foods, someone asked if LifeinU BSCU1 is suitable for cereal bars.
Yes, for sure. LifeinU BSCU1 is suitable for cereal bars. We developed some specific prototype. Then, if you are interested, do not hesitate to contact us, and we can, let's say, provide some kind of information on how to process LifeinU BSCU1 and a kind of let's say recipe and support in designing some new cereal bars.
Okay, next question. Who is selling this product in the U.S.? We sell the product in the U.S. This by Lesaffre. Then same thing. If you are interested to receive some samples, do not hesitate to contact us in order to receive samples. And we sell directly in the U.S. We are based in. We have also. We are based in the US also,
even I have a French beautiful accent. We have some American colleagues which are based in different places in the US.
And are there any additional studies taking place?
Yes, I mean, as Julie said during the presentation, we are now in a program, scientific program around the CU1, the Lifein UTM BSCU1. And of course, the results I presented today are really upfront results, preliminary results on the model, and for sure we will have more to come soon. So yes, we will have more.
Here's an interesting one. Is this model relevant to probiotic evaluation as well?
That's a very good question. For the moment, as far as I know, not yet. I mean, there are some developments, and you can find some information about the use of such gut-on-chip model with the addition of a full and complete microbiota inside. Because once you want to address the question of a prebiotic, you will need to co-cultivate the cells coming from the gut with the microbiota, so the bacteria in the gut, to see if there is some fermentation of the components. So as far as I know, there is no model existing right now, but there are some which are developed at the moment. I think that's for sure addressing the question to emulate would be of interest.
Okay, I think unfortunately we are out of time. I want to thank the audience for attending and participating in today's event. And I would like to thank our speakers and our sponsor, Gnosis by Lesaffre, for making today's educational webcast possible. We'd like to ask everyone in the audience to participate in a brief survey. You can see the survey in the right-hand side of your screen. You will receive an email alerting you when this webcast is available for replay. That will include the slides. We invite you to forward the announcement to your colleagues who may have missed today's live event. Thank you all for joining, and we look forward to seeing you next time. Thank you. Bye-bye.
Thank you. Bye-bye.